Welcome back. Hope you enjoyed your lunch. We shall now proceed with the agenda and open our third session with two work strands. The first, led by Portugal, will address the vulnerabilities of autonomous vehicles to cyber attacks, and the second, led by Turkey, under the title Change in the Conduct of Naval Operation, in which way unmanned systems can be integrated. After each session, we will have a 10-minute discussion period. The first work strand will be presented by Lieutenant Commander Mário Monteiro Marques. He holds a PhD in Electrical and Computer Engineering from the University Nova de Lisboa and is currently researcher and professor at the Portuguese Naval Academy. Lieutenant Commander, the floor is yours.
Good afternoon, Admiral Chiefs of European Navies, distinguished guests, Excellencies. I'm presenting today the work strand developed by the Portuguese Navy, the vulnerabilities of autonomous vehicles to cyber attacks. I will follow this agenda. First, I will begin with an introduction. Second, I will explain the complexity of unmanned systems and present a reference advanced model. Third, I will talk about the cyber vulnerabilities of unmanned systems and suggest one approach to mitigating them. Fourth, I will discuss the status of unmanned systems in European navies. And finally, I will share some conclusions. Starting with the introduction. Nowadays, one of the most valued resources is information. Unmanned systems are heavily dependent on cyber systems, which are used to collect, store, and process information. All the components of the unmanned systems are susceptible to cyber attacks. The aim of our work is to identify the vulnerabilities of the unmanned systems and understand the status of autonomous vehicles' vulnerabilities to cyber attacks across European navies. To do this, we studied the unmanned systems components, verified their cyber vulnerabilities, and studied a defensive model, and we also sent a questionnaire and compiled the results to understand the status of autonomous vehicles in European navies. First, we need to understand the unmanned systems environment. Unmanned systems are changing the way military and civil operations are carried out. We can have multiple unmanned vehicles performing various types of missions simultaneously. These vehicles are produced by different companies with different specifications and protocols, making interoperability difficult. These multiple information sources are not integrated, and each system may require a specific terminal and operator. As a result, the decision maker receives all the information in an unstructured way and makes the decision. But we cannot forget that all these systems are mostly electronic, and they can be target of cyber attacks. This has already happened several times. In 1997, Hezbollah intercepted a video feed from the Israeli unmanned air vehicle that resulted in an ambush of the Israeli commandos and several deaths. In 2011, due to a GPS spoofing attack or a technical malfunction, Iranian forces captured a Sentinel, and it was used by the regime for propaganda purposes. Afterwards, Iran was able to reverse engineer and produce an Iranian version of the vehicle. Also, in 2011, the Predator and Reaper operations in Nevada were disrupted by unknown actors' virus attack on their ground control station. Portugal is using more than one type of vehicle from different companies, and to be able to make them interoperable, we developed a reference model. The model has three main blocks with subsystems and components: the vehicle, the data link, and the ground segment. The reference model described in detail in the documentation that you will receive encompasses a very wide range of existing unmanned systems. The model allows these unmanned systems to be compared and described, allowing efficient development of interoperability protocols. The benefits of the common reference model include easier interaction and cooperation between unmanned systems, enabling a single control station to control more than one system, avoiding the forest of computers, software that will be reusable between different systems, training will be easier because of common components, economies of scales will lead to lower prices, the logistic chain will be simplified because we will use in many different systems and from many different vendors, and finally, fewer systems will lead to simplified maintenance processes. But as I said before, all these systems are mostly electronic and networked, meaning that they can be target of cyber attacks. Security has to be ensured during the storage, operation, and the transit of the unmanned systems. Security of data can be defined in terms of three main attributes: confidentiality, integrity, and availability. Cyber attackers will exploit vulnerabilities in software, security policies, and communication technologies to gain the ability to perform unauthorized actions. Generally, we can categorize the attacks in three types: hardware attacks, which can occur whenever an attacker has direct access to the unmanned systems components; data link attacks, which can occur if the attacker used wireless communication to change data on board the unmanned systems; and sensor spoofing attacks, which are directed towards onboard sensors. Let's look at how these attacks impact the elements of our reference model. Hardware attacks can occur on both the vehicle and the ground segment. Our data link is subject to the data link attacks. Several main systems and subsystems are vulnerable to sensor spoofing attacks. But if we all use the same reference model, we can better invest in cyber operations and increase our resilience. For that, we have to establish a defensive architecture based on defense layers and recover procedures. The defensive architecture has a inner and outer perimeter. In the outer perimeter, we can deploy Unnets or decoys before the system itself is reached. If the system is attacked, those Unnets will appear to the attacker as the joint system and will deflect incoming attacks toward those decoys. But if some attacks will enter in the inner perimeter, these are true intrusions to the system. We must have measures in place to prevent such intrusions. We use active scans to detect intrusions and blocking measures to block them. But if an intrusion is not detected, the system will be compromised. In this case, we need to have the right procedures and hardening measures in place that allow us to recover from the attack and proceed with the mission, or tolerate and proceed with the mission in spite of it. But if the system is not full torrent or recoverable, then we can lose the system. Now I will present an overview of the status of European navies, unmanned systems operations, and cyber vulnerabilities. We sent the questionnaire to the 26 nations and received 16 incomplete answers. Thus, the results are not scientifically valid and do not provide statistically valid results. Nonetheless, they provide us with needed insights. The aim of the questionnaire was to collect the status of autonomous vehicles vulnerabilities to cyber attacks across European navies. The questionnaire was divided in two parts with different purposes. The first one concerning general information to understand the status quo of the unmanned systems in these countries. The second one concerned autonomous vehicles vulnerabilities to cyber attacks. The objective was to understand the level of cybersecurity awareness on unmanned systems and the existing doctrines and the operational procedures. What we learned from the questionnaire was that unmanned surface vehicles are mainly used for mine warfare and additional marine warfare operations. Some nations have operated these vehicles for more than 30 years. New applications and designs are being tested for military and civilian use. Unmanned underwater vehicles are used for operational and environmental data collection, explosive ordnance disposal, and mine countermeasures, some nations have operated these vehicles for more than 20 years. Unmanned air vehicles are used for data collection in real time, operational surveillance, target reporting, weapons delivering, and targets for firing practice. Almost all navies operate or are in the process to use unmanned air vehicles. Some nations have operated these vehicles for more than 10 years. Unmanned ground vehicles are used for explosive ordnance disposal. Some nations have operated these vehicles for more than 15 years. The integration of the unmanned ground vehicles in amphibious operations is at an initial stage of development in some European navies. Some navies also reported the capability to use unmanned vehicles in swarms or wolf packs. The use of swarms in the same task is foreseen as a major force multiplier in the future of naval and amphibious operations. Concerning the second part of the questionnaire, referring to the cybersecurity of the unmanned systems operations, we could conclude that, in terms of doctrine, European navies have established doctrine and operational procedures concerning the use of the unmanned systems, but only a few nations have specific doctrines concerning how to cybersecure these systems. In terms of training, unmanned systems and cybersecurity are considered separate issues. In terms of material, the data link is considered the weakest link in cybersecurity. So, what are the main takeaways? Unmanned systems are composed by cyber systems and are vulnerable to cyber attacks, as shown in the past. The reported status of the European navies shows that there is still room for improvement concerning doctrine, training, and material. A common reference model would increase the overall development of cybersecurity and interoperability of the unmanned systems. And interoperability is a paramount. Because we're working together, we go further. Thank you. I'm now available for your questions.
Thank you very much for your presentation, Lieutenant Commander. Once we are right on time for the second work strand, we'll start it. And if you have any questions, even for the first speaker, you can pose them in the end of the period. For the second work strand, we will have Commander Beris Bilgili. He is a staff officer at the Turkish Navy Staff Operations Branch. Commander, the floor is yours.
Thank you. Admirals, colleagues, distinguished guests, it's an honor for me to address you today. I'm Commander Bilgili, Turkish Navy Operations Department, Concept Development Branch Head. I will inform you briefly in 15 minutes about change in the conduct of naval operations, in which way unmanned systems can be integrated. Actually, the topic is multidimensional, but I will try to outline the basic themes in the given time frame. The agenda is on the slide. As of today, more than 75% of European external trade transits through sea. Also, most of the natural gas and oil are obtained from the sea. And this is the core of economy. For the wealth and survivability of a nation, it is essential to provide security for the sea lines of communications, which in turn will support our main mission, the defense and protection of our homelands and national rights and interests. For this reason, and to accomplish our missions, we navies must have the necessary platforms and qualified personnel. The functionality of the navies are restricted by the number of platforms and personnel, budget limitations, and geographical constraints. For these reasons, Navy can't have the adequate number of capable ships, platforms all the time. The number of ships in the Navy's fleet determines where we can be and what we can do. But mere numbers are not enough. What a platform can do, how capable it is to create an effect, is increasingly important. But is this enough? I think it's not. Do we have capability and capacity shortfalls, challenges? Yes. Are the platforms that we use cost effective? Probably no. How we can cover these gaps is the question mark. The technology is the answer. We can use, and we are using, unmanned systems for these reasons. How can unmanned systems help us in all these domains? They are obvious, clear amplifiers, force multipliers. So, how can we leverage? How does the technology fit in? Unmanned maritime systems are not an entirely new phenomenon. For instance, they have been used for mine clearing and battle damage assessment since the Second World War, notably in Vietnam and during Operation Iraqi Freedom in 2003. However, it is only the 21st century that unmanned systems became the subject of aggressive technological progress and operational concept development. Use of unmanned and autonomous systems creates situational awareness, and this in turn provides us with quick reaction opportunity. Their integration will provide reductions in manpower and risk to personnel, lower operating costs, increased persistence, faster and more accurate data processing, and a faster decision cycle. Navy's unmanned warfare systems goal should be to fully integrate unmanned technology in naval operations, because unmanned assets will enable naval forces to understand quicker, act faster, and adapt continuously. Over the past years, there have been numerous studies conducted by the navies and several other organizations that have explored what the future fleet should look like. Two conclusions consistently emerge from this body of work. First, the nations need a more powerful navy to accomplish its missions that includes a combination of manned and unmanned systems. Second, more platforms are needed, but that is not sufficient. The Navy must also work on coordinated use of manned and unmanned systems together. This means we should work on new operational concepts. Employment of manned and unmanned teams and technologies will transform modern warfare, increasing asymmetric and hybrid operations, leveraging the technologies to the Navy's advantage and give the warfighter the edge to win the fight. Most of the navies continue to incorporate unmanned systems into their existing organizational structures. So it is obvious that the future operations will rely heavily upon multi-domain capabilities that must interface and integrate smoothly into a joint force structure. And even now, this force structure is combined with manned and unmanned systems. Maritime unmanned systems have already proven themselves in naval operations, such as MCM and ISR so far. Unmanned systems will strengthen naval power at, on, and from the sea by reducing operational risk and cost. And unmanned systems operating in the air, on the surface, under the sea, and on shore as a rapidly adaptable and interconnected network will provide access to areas denied to manned platforms, provide better situational awareness, increase capabilities with greater range and persistence, and enable faster decision making. With all of these major advancements, challenges, and trends can be consolidated into 4 critical themes, which address foundational areas of interest that will continue to accelerate the integration of unmanned systems into the future Navy. Those are interoperability, autonomy, network security, and human-machine collaboration. Interoperability has historically been and continues to be a major thrust in the integration and operation of unmanned systems. In a force with a dynamic mix of manned and unmanned systems, it is imperative that unmanned systems are able to communicate, share information, and collaborate with one another and human counterparts across systems and domains. In tomorrow's operational environment, it will be imperative that forces and systems can communicate among multiple command levels across various units, share information and tasking, and assist mission leads as events played out on the battlefield in real time. Part of the real challenge is how to integrate it into the way we fight and into all these platforms. I think the best way is to deploy and work with those assets next to the platforms they would be integrating with, both in the air, on the water, and underwater. So, What should be done in order to gain more interoperability? Initial focus should be on C2 and common architectures that improve interoperability. Modularity should be designed into systems, will enhance shared capabilities and safeguard against system-wide vulnerabilities. A data strategy should be created that is agile, responsive, adaptive, and protected. Autonomy. Autonomy is defined as the ability of an entity to independently develop and select among different courses of action to achieve goals based on the entity's knowledge and understanding of the world itself and the situation. Advances in autonomy and robotics have the potential to make revolutions in warfighting concepts as a significant force multiplier. Autonomy will greatly increase the efficiency and effectiveness of both manned and unmanned systems, providing a strategic advantage for the Navy. Increased autonomy will enable unmanned systems to perform a greater range of tasks, which will directly increase operational capability. Greater autonomy will also remove the need for constant input from human operators. This will allow for higher level control or supervision of multiple unmanned assets simultaneously, like swarms, and will increase effectiveness by reducing the operator's cognitive load, allowing operators to make command decisions and perform other high-level tasks. So, what should be done for autonomy? Industry should invest on artificial intelligence, machine learning solutions. To accomplish this, data collection, standardization, and sharing needs to be addressed throughout and across the services. Navies must also continue to lead the national and international discussions concerning artificial intelligence perception, policy, and laws. Advances need to be made that increase operational safety and efficiency, such as in-air collision avoidance and automated safety features for maritime vehicles. Human-directed tactical tasking of unmanned systems and the overall performance of these systems should meet all ethical requirements for the rules of engagement and the law of armed conflict. Network security. Unmanned systems operations ordinarily rely on network connections and efficient spectrum access. Network vulnerabilities must be addressed to prevent disruption or manipulation. In today's environment, where many of an organization's mission-critical functions are dependent upon information technology, the ability to manage this technology and to assure confidentiality, integrity, reliability, and availability of information is essential. The security of information systems is a focal point for commanders at all levels. This problem is especially apparent in unmanned systems, which by their very nature have an elevated reliance on information systems to function safely, effectively, and consistently. What should be done for secure network? Layered protection for unmanned systems should be developed and implemented to combat cyber threats. To counter electronic attack, unmanned systems must be designed and built with robust electronic protection capabilities. Human-machine collaboration. If interoperability lays the foundation, then human-machine collaboration is the ultimate objective. Teaming between human forces and machines will enable revolutionary collaboration where machines will be valued as critical teammates. Human-machine collaboration is essential to meet the unmanned systems vision for an integrated manned-unmanned force that strengthens the navies. Naval operations of the future will require more collaboration between unmanned systems and humans. To ensure agility, the human-machine interfaces must support a range of control options whereby the human can be either off the loop with no control over an autonomous system, on the loop supervising the unmanned systems, or in the loop exercising commands to control a particular vehicle's path or payload. The goal of human-machine teaming is to produce synergy and overmatch with asymmetric advantages by combining the inherent strengths of the warfighter with manned and unmanned systems. As operators use systems that routinely achieve expected and predictable outcomes, trust will evolve and human-machine teaming capabilities will be refined. What should be done for human-machine collaboration? Operator-supervisor control of multiple unmanned systems should be developed. Human-machine interface should be developed to dynamically establish human autonomy roles in task completion. Improved automated decision support should be developed. We should increase the payloads of unmanned systems to lighten the workload of human. So, what are we doing as Turkish Navy? We are in coordination with NATO COEs and organizations such as MARSEC COE, COE CSW, CJOS COE, and CMRE. We are leading the engagement with national industry and organizations to ensure a full understanding of current and future systems and technologies being offered or developed by industry and to ensure a common understanding. In order to ensure the cyber resilience and efficient use of unmanned systems, efforts are being made to develop processes and technologies integrated into tactical data link and combat management systems that will ensure safe command, control, and communication. Our HQ, Warfare Center, and training commands are working and reviewing on concepts, doctrines, and tactics. We are experimenting and improving these tactics in our exercises. Turkish Navy is also leading the Turkey's declaration of intent concerning multinational cooperation framework for the introduction of maritime unmanned systems capabilities, which is signed by 13 ministries of defense on October 2018. In conclusion, and in light of the issues mentioned, to protect and to defend our homelands and national rights and interests, to deter and prevail over adversaries, we must see further, understand quicker, act faster, adapt continuously. What capabilities do you want for your Navy? I think it is going to be these bullets. If you can do these things better than your adversary, you are going to win. So, if you agree, how can unmanned systems help you achieve these goals? The answer is working through them and learning continuously. This is the area where we are leveraging the power of machines and what they can do for us, fighting at machine speed. It means simply quicker than your opponent does. Navies must be able to operate in littorals as well as open seas, blue waters, where there is primarily fleet-on-fleet action. Getting closer to land, the threat to the platforms will be more intensified. In each zone, the Navy must be able to operate with sufficient numbers of the right kinds of capabilities to attack, deceive, and defend against adversaries, missiles, submarines, and cyber and electronic attacks. So, the future fleet will need to be larger and more capable with the right kinds of unmanned systems. There is no question that unmanned systems must also be an integral part of the future fleet. The advantages such systems offer are even greater when they incorporate autonomy and machine learning. And these platforms must be affordable enough to buy them in large numbers and network in order to expand our presence in key areas. In addition to these issues, we also have other challenges. Some of these are lack of unmanned system standardization, legal and policy constraints, lack of trust, lack of understanding human-machine interactions, C2 complexity, vulnerable networks and cyber attack vulnerabilities, weaponized unmanned system policies, tactics, techniques, and procedures. But in the end, the Navy's vision has to be to have unmanned systems operable as an integrated part of the force as we go forward, teamed with the naval assets, delivering decisive combat power and support to naval operations cost effectively. This is the end of my presentation. If you have any questions, I will gladly try to answer them.
Thank you very much, Commander Beris Bilgili. We'll now have the discussion period. This is the price you have to pay for speaking after lunch with Portuguese wine. Sorry. The business agenda item. 2 requests were received, one from the Portuguese chairmanship and another one from the Italian Navy. Commander Alessandro Trivisone from the Italian Navy will now brief us on the developments on the military Erasmus program. Commander, the floor is yours.
Head of CHENS Navies, dear CHENS POC colleagues, ladies and gentlemen, first of all, thank you for this venue to show up a couple of reflections we have made about a possibility of exchange in terms of education in the military framework. We have seen today that to be relevant and successful, we need to be interoperability. And interoperability starts from commonalities. And commonalities starts from education. The education domain, on our point of view, is ideal to strengthen the ties of cooperation between our navies. Moreover, positively orienting the education of the midshipmen today may result in providing a generation of successful leaders tomorrow. So, for this reason, we evaluated that there are a lot of possible initiatives we could go through in terms of common education. It's not a new idea. It has already been explored in the past. We have several examples of exchange of cadets between academies. However, this is normally happening on the base of a continuous and complete training program that has possible difficulties and problems we face when we go into it. Because possible common initiatives are always influenced by tough educational programs, because the cadets have very few moments to be educated, language difficulties, because when we have to send a cadet in another academy, we have to afford the course in the language of the hosting nation, nation sensitiveness, and also for the European Union nation that are relying on the Bologna Convention, university regulations. As Italian Navy, we could mention a couple of success histories about our experience. We have had for a very long time a successful exchange with the French Naval Academy in Brest. And we have also an exchange program with the US Naval Academy in Annapolis. But those are programs based on the possibility to send a cadet in another academy and to embed him in the education program of that academy. But we wanted to achieve more. So we decided to go through a scalable project meant to accomplish full compatibility by design. We launched an initiative within, but not limited to, the European Defence and Security College framework. It was discussed on last February, and that at the moment there is a dedicated working group involved in the implementation roadmap. The main topics we had on this project, we were aiming at pursuing an extended and pervasive exposure to the European environment. We were looking to provide the same subjects within the same credits and the same time and in the same language in order to achieve this interoperability. We wanted for the cadets to enjoy full compatibility by design. So we decided to go through a scalable roadmap on which the first definition would be on next September. And the full implementation will be in 2023. I will show shortly after the roadmap. The exchange, in principle, will be limited to 3 months, generally speaking, the beginning of the training period for our cadets, so October, November, and December, will be based on a modular structure, will be held completely in English in order to don't have such problem with language training before having your cadets join in the project. And for the one who will be interested, once fully implemented, will be capable to grant 25 ACTS credits, 30 if the cadets will afford the physical training, and will be providing equivalent competencies into the different academies. However, we wanted to keep the momentum, and pending the implementation throughout the ESDC, we decided to start an experimental version of the semester from the next September until the project will be fully implemented by 2023. This is the roadmap of the project, and these are the main subjects that will be fully available for your cadets during the semester. The whole program has to be seen as a basket from which you can pick the element you prefer. Your cadets won't be asked to be present for the whole time. They can even afford each single module, and then they will receive a certification from the Naval Academy. The Naval Academy superintendent has already issued an invitation to the counterpart and with which he has normally relationship, but we wanted to take the occasion of this valuable venue to open the door for the project. I mean, it's ESDC qualified, but it's not only for ESDC interest countries. We really and strongly believe in commonalities in terms of education, so we will be very happy if you want to join us in this enterprise. The doors are open starting from next September till the full implementation of the program. And thank you for your attention.
Thank you very much, Commander Alessandro Trevisani. Now we'll have Captain Nuno Sardinha Monteiro, Head of the Resources Branch at the Portuguese Navy Staff. He will present the Portuguese offer to establish a NATO Center of Excellence in Maritime Geospatial Information, Meteorology and Oceanography.
Good afternoon, ladies and gentlemen. It's a great pleasure to address this distinguished audience. It's also a great challenge because I'm the last briefer, but I'll try to keep it very short. And to start this presentation, I would like to remind the audience about the concept for centers of excellence, for NATO centers of excellence. NATO centers of excellence are described as multinational entities that offer recognized expertise and experience to the benefit of the alliance, especially in the support of transformation, but also supporting on a case-by-case basis operations. COEs are activated as NATO military bodies, but they are not part of the NATO command structure. This gives them great flexibility, and as I usually say, they have one foot inside NATO because they are activated as NATO military bodies, and they have another foot outside NATO because they are outside the NATO command structure. Using a word that is very common in military circles, they have a hybrid status. They have great flexibility. And that flexibility allows them to have, to establish and maintain relationships with other external entities, namely non-NATO countries, international organizations, academia, and the industry, the defense industry. In terms of structure, COEs are generally comprised by one framework nation, in some cases two framework nations, but generally it's one, which is the nation that develops the COE concept and provides initial infrastructure, equipment, support personnel, and administrative support. Besides the framework nation, there are generally several sponsoring nations that provide manning, funding, and other support or resources. And COEs are also open to contributing partners, which can be any non-NATO nation, organization, or entity that provides or wants to provide a contribution to the COE. Since the approval of the Military Committee concept for Centers of Excellence in 2003, the first COE was established in 2004, and in the 15 years afterwards, 25 COEs have already been established. They are depicted here in this slide, but allow me to stress the 3 maritime COEs: the Combined Joint Operations from the Sea Center of Excellence in Norfolk, United States of America, the Operations in Confined and Shallow Water COE in Kiel, Germany, and the Naval Mine Warfare COE in Ostend, Belgium. And in line with the current policy of NATO to reinforce the maritime posture of the alliance, we have 2 more maritime COEs in the pipeline, in the establishment process. The Maritime Security COE in Turkey and our own Maritime Geometok COE, specialized in the fields of geospatial information, meteorology, and oceanography. And the vision we have for our Portuguese COE, our NATO-accredited COE, is to be an internationally recognized hub of expertise in the field of maritime geometok, working to expand the capabilities of NATO, nations, and partners, here including the European Union. And the mission of the COE will be to enhance the transformation efforts of NATO nations and partners in the field of maritime geometok. To accomplish this vision and this mission, we have drafted this organizational chart, which is open to inputs from the nations. And allow me to make 2 notes about this chart. The positions that are here depicted in blue are the ones that are reserved for Navy personnel. The ones that are depicted in purple, they are open to all services, although we expect most of them to be filled by Navy personnel. The positions that have the Portuguese flag, they are reserved for Portuguese personnel. All the other ones are open to the contributions and to the offers from the nations. Now, I would like to explain a little bit, very shortly, the establishment process of the COE. Establishment processes of COEs have 4 steps. We are currently in the 2nd step. The first one was the development of the COE concept. We have a preliminary version of that COE concept, and the COE was offered to NATO on January this year. It's important to stress that this COE is based on a center, a national center that we have already working, supporting operations and supporting transformation. So it's a capability that we have, and we want to make it multinational with the offers and the participation of as many nations we can attract to the center. So the COE was offered to NATO on January 2019, and now we are in the 2nd step, which is the information campaign. And naturally, this presentation is also a part of that information campaign, where we try to attract sponsoring nations and contributing partners. During this phase, this step, we have 2 major milestones, which are the 2 establishment conferences. And I would like to announce that we will have the first establishment conference here in Lisbon, in the Portuguese Hydrographic Office, from 9 to 10 of October this year, and the 2nd establishment conference on the 4th and 5th of December, also this year, in Lisbon, in the Hydrographic Office, in the Portuguese Hydrographic Institute, next to the center which we have already up and running. The first establishment conference generally is to finalize the COE concept with inputs from the nations, from NATO, and from other international organizations. And the second establishment conference is dedicated to draft the memoranda of understanding that will be signed a couple of months afterwards. After the MOU signature, which closes the second phase, we will have the accreditation phase, which is conducted by NATO's Supreme Allied Commander Transformation, and then the accreditation itself, which implies the military committee approval and the North Atlantic Council endorsement, and our plan is to have the official opening ceremony of the center, NATO Accredited Center of Excellence, by the end of 2020. To end my presentation, I would like to give you and to leave you with three major takeaways. The first one is that we have a center working in the geometric field, supporting operations and transformation, which we offer to NATO, and we invite all allied and partner nations to be a part of this COE. The second takeaway is that we will have the first establishment conference on the 9th and the 10th of October. There's a small mistake in the slide. It's 9th and 10th of October, and you have that information on the flyer on your tables. And the second establishment conference will be on the 4th and 5th of December. Thank you very much for your attention. It was a pleasure.
Thank you, Captain Monteiro. Admirals, ladies and gentlemen, proceeding with the schedule, and before we start the fourth and closing session, the chiefs of European navies and heads of delegation will now have a closed session in this room. Coffee will be served during the session. The remaining guests and delegations are invited for a coffee break at the foyer on the first floor. We will reconvene whenever.